Number 3, we're going to find the equation of hyperbola with vertices at negative 2, 1, so negative 2, 1, and positive 2, 1, which means my center is in the middle at 0, 1, and it passes through the point 5, 4. So it means my graph is going to go this way, this way. So that means my numerators are x squared, y minus 1 squared, and it opens right and left, so the y is negative. I know that my distance to my vertex is 2, so 2 squared is 4. I don't know what underneath my y minus 1 squared is. But I do know that I have the point 5, 4, which is my x and my y, so I'm going to plug them in. 5 squared over 4 minus 1 squared over question mark equals 1. That's 25 fourths. Minus 4 minus 1 is 3. 3 squared is 9. For question mark equals 1. And so if I want to solve for question mark, I'm going to move over the 25 fourths. Negative 9 over question mark equals 1 minus 25 fourths. I'm going to make that smaller so that you can see what I'm doing. Then negative 9 over question mark equals 4 over 4 minus 25 over 4 is negative 9 over question mark equals negative 21 over 4. If I cross multiply, we're going to get negative 36 equals negative 21 question mark. So my question mark is 36 over 21, which reduces if I divide by 3 to 12 over 7. So my denominator becomes 12 over 7. And that's my equation. Okay. Suppose John and Jane are standing 3 miles apart and both see a flash of lightning. After a period of time, John hears the thunder. 4 seconds later, Jane hears the thunder. If John is standing due west of Jane, and the lightning strike is known to occur due north of John, sound travel. What is the equation of the sound travels at 1100 feet per second? What is the equation of the hyperbola? So you have 2 people, John and Jane, sitting on the foci, and this is where my lightning occurred. So I want to find the equation of the path of where the lightning occurred. So the first thing I know is that my distance between the two is 3 miles. And I have to convert that to feet because we're doing feet per second, so you have to have the same measurements. So if I multiply that, I'm going to get 15,840 feet. Okay. However, the distance from my center to my focus is C. And that's 2C. So 2C equals my 15,840. So if I divide by 2, I'm going to get 7,920. So the first thing that you do, I'm going to write this in green, is to find C. You're going to take whatever your miles are that I give you, times 5,280, divide by 2. That's step 1. Okay. So I'm going to add another screen onto this to do the next step part of it, to get A. Okay, so again, you have John and Jane. You have your hyperbola branches here, and they're standing on the foci. Definition of a hyperbola is the distance from one focus to, one focus to a point on the graph to the other focus. That difference in distance is equal to, is equal to this length from here to here, and we saw that in class, and that is 2A. So my 2A equals my D2 minus my D1. So that means A is D2 minus D1 over 2. However, I haven't given you difference in distance in this problem. I've given you difference in time. I told you that the difference in time between when the 2 heard it was 4 seconds apart. John heard it first, Jane heard it 4 seconds later. I need to turn your difference in distance your difference in time into a difference in distance. And you do that by distance equals rate times time. So my difference in time is equal to my rate that sound travels, which is 1,100 feet per second. Sorry, that was just CVS calling. To my difference in time. And so my difference in distance is 1,100 times my 4 seconds. So that's going to give me 4,400. So in this case, we're going to move this up a little bit. In this case, my A is equal to my difference in distance. Over 2, which is going to give me 2,200. So your second step, I'm going to move this up here so that I have some room. So your second step in general, let's do this in green. Second step, just like I did on the other screen, to get your A, you're doing your 1,100 times your time that I give you divided by 2. That gives you your next number. Okay. I'm going to add another screen. So to summarize so far, to get your C, you're doing miles times 5,280 divided by 2. To get A, you're doing your speed of sound, whatever I give you, times time, divided by 2. And the last thing to do is to get your B, your A squared equals, your A squared plus your B squared equals your C squared, to get that. So with all that being said, my C was 7920. My A was 2,200 from the previous screens. So then to find my B, you have to do Pythagorean theorem, and you should come out with B is 7608. Since my parabola is opened up left and right, we're just going to make the center 0, 0. So that's x squared minus y squared. Since it's opening right and left, we will have the x part positive and the y part negative. Underneath my x squared is my A. That was my distance to my vertex. So that's 2,200 squared. And then underneath my y is, I forgot the 8, is that squared. And since these numbers are huge, you can leave it like this. This is the equation of where lightning could have occurred on a parabola. Part B says the lightning occurred directly above John. So that means John was here, and they're saying the lightning occurred directly above him, right there. So as a coordinate, we already know that the whole entire distance from foci to foci was 15,840 miles. So that means to John, that distance with C was half of it, 7920. And if this is at 0, 0, that means this coordinate up here, let me change my pen width and change color, is negative 7920, comma y. So I don't know. So all I'm going to do is plug this into my equation. My hyperbola equation we did on the last screen, and solve. So I don't have enough space on the screen, but you're basically going to move this over here, multiply by -1, multiply by 7608 squared, and square root it, and you should get your y is 26,310 feet above John.